All right, let's get started. Welcome to this video. The topic of this videos is about the card generators, and you look like it's a little bit like OP, but so what's going on over here? So let's talk about it. All right. All right, so here's the code that we are looking at. So this card generator, one thing you notice is I start using this colon syntax, right? And so in the card test, the card generator test, right, you see that I am actually creating this instance and then calling it like an OO. Right, so hey, Homa, aren't you keep talking about it should go going functional, but why suddenly a change of mind, right? But actually, what I'm showing here is not really OO per se. Is the way that Luna is supposed to work. In the sense of similar to Rust is data-driven or data-oriented programming. So, but from the outside, it looks a lot like OO. And here's why I am switching for this code and also some other code also, I'm switching over to this model. The primary difference between the functional approach that I have versus this is it allows this data oriented programming allows you to organize the methods a little bit better or essentially scope it down a little better so that when you read the code it flows a little bit better. So what I mean is this. So say for example let's assume, because I'm not going to change the code, let's assume and change this back to using the dot syntax, right, like that. So if that is the case, let me keep it there for a moment. That is the case. The only difference between that one and this code is that when I'm creating it, so let me copy this. I'm creating it. I will creating it use the dot syntax obviously, and then the next line would be written like this: card generator dot generate, and then I will pass the context in. Well, actually for the demonstration purpose, let me switch it over. So let me copy this and place this over here, and then do a dot. And of course, some of this code changes. And essentially, in this case, since I'm not constructing an instance, quote unquote, an instance of an object, all I'm doing is just returning this. And let's keep the other code the same. Right, so it will be something like this, and then in the generate function I will receive this context. That's when you see this just looks like the original code that I have or the other code that I have, and is calling up like this, right? So that's the only difference. And then when I'm calling it, I will be passing in this gen and then pass in this option, okay, like that. So that's all the difference there is, right? So it's just that the call will be specifically taking in the object that returned from the new function or in this case, I really don't need this anyway, do I? I can just say this, right, like that. And then let me comment this out. And then if I run the test, assuming other test is okay, then supposedly this would work fine. But right now here, you can see that the test that's failing is actually the exploration test, not this one. This one is passing, right? This test is passing. That one is failing because that code is using this code, which is doing the instant class thing. So that's why that is failing, but this is passing, you can see, and it's really not much of a difference. Then why the change? Again, is really for just making it looks and scope a little bit better, because if you compare this code with this one, no, with this one, the only difference besides creating it is this call, it call like that versus calling like this, right? So this makes it a little bit easier in terms of consuming the code, and I know that this is more, you know, going back to the old side of things about organizing the code, and but that's just that's it, right? And also, well, it makes it a little bit easier in consumption. So let me go to the exploration code. Is the code is like this, right? So I have this card generator. I create a new instance of it, and then I call generate, right? So I didn't really save much in terms of typing and in terms of importing, because I'm importing this card generator anyway, right? I'm entering, so I have to import it anyway. So it's the same, but it's just that since I have to keep that around, and so this is another way to make it, you know, just a little bit a tad easier to use. So you can see, for example, over here is just call this generate instead of calling it like this, because calling it like this meaning, well, I still have to keep track of this card generator object and then passing it into the function. So the difference is very small, but you can see, you know, in this example, how easy it is to transfer or transform between functional programming and to data-oriented programming. Now back to the topic, why this is not OO. Well, in a sense, it is, because you can see that over here, in order for this to work, I have to do the whole, you know, OO thing of creating, using this set meta table, setting this index and all those stuff to make it work, right? But the fact is, this is a limitation of the language itself in order to do this data-oriented programming and support the syntax like so, like doing this, right? Because the reason is the compiler needs to know what's the type of this object, and so that it can bind the function, in this case this generate functions, to that object, right? What I'm describing is a kind of a high level sense of it, because in reality it is what it is, because you are creating a new instance of this class, quote unquote, and so with that you inherently you have the type, and so it's natural for the compiler to understand that, oh, there is a generate function for this instance, or essentially this object, right? So then, you know, then what's the point? Again, what's the difference between this and OO? The difference between it is in, well, the main difference is that the functions are separated from the definition, the clear definition of the object itself, meaning just like in the in these where they like say for example in the spec file in the gateway, right? While over here I'm using the function override, but the concept is the same, that you can attach additional methods to the whatever class of there is, and then you're able to use it that way. So what I mean here to better demonstrate it is like this. So say right now I have this new and generate, right? And this is the class, right? Assume, pretend that this is normal OO for a minute. So you have new a constructor, and then you have a generate method associated with this class, right? So then I get this over here, and what I can do is I can declare another function. So over here, say card generator full, and then return full, right, over here like this. Okay, so this is not possible in traditional OO sense, right? Because this is not part of the class, right? But over here, I haven't tried it, but you should able to do it. So let me create a function. Nah, I don't need that. I don't need all those things. Right. So with that, and then let me just copy and paste this, and then assert r equal, and then full and gen full. Okay, if things goes fine, this will work. Alright, so yes, it does. It didn't work over here because, well, this was wrong. Well, because I have this function, so let me remove it. So you can see that is passing. Right, this test is passing. You know, say if I do this, you can see that it passed in full, and but is I'm expecting full though. So I make it fail just to see the result, right? So you can see that the instance we can attach additional methods to it, right? That's the power of Lua, and also like say in Rust allows you to do, which you can't in OO without traditional OO language, without doing subclassing, things like that. And sometimes in other language this is also called mixing, but the concept is very similar, right? Very similar. And so this is, there are some there's the power, let's put it this way, there's the power that the DOP provides you, or the language is essentially provides you, but at the same time it can get abused, right? It can get abused. So let's talk about that a little bit. So since, especially say in Lua, it's just a script, right? It's a scripting language. So it means that if I'm doing it over here, and then if I have another class or another file that have access to, they import this or throughout the life cycle of the program, it reads this file. Then potentially, over here, even though the card generator class, the module itself, have not defined this full method, you were able to use it over here, right? And that will make your code a lot harder to manage, because now you have a hard time to find out, hey, where is that method is defined. Right, so be careful about that. And the best practice of doing things like this is two things. One, when you define a function like this over here in one class, make sure that that is only used within that file or within that submodule. So for example, say, although in the example here I'm showing you this is just a test file, but it can be a subsystem of your application. So when you can do that, you can add something over there, and then so all of your subsystem can say in reference this file so that it have all these functions available to use. But be careful about it, be conscious about it of what you're doing so that you won't run into problem. And then the other thing is pay real close attention on changing states, right? Basically changing the data that instance contain, right? So sometimes that's the main difference between functional programming and other paradigm, right? Because in functional programming, if you talk about purely functional programming, you're not supposed to change state, and it definitely have its benefit. It makes the code easier to understand. But with this, you might run into some problem, or some harder to understand things. But in general, it should be okay, because as long as the module / class itself has a clear definition of what is quote-unquote public and what is private, then these functions that you declare on top of those are just additional helper functions for that class. Right. So one of the things that you should never do is to expose the private properties, the data in your class or in that the other functions can access. So that goes with anything. So meaning, say for example, you have a data called x equals to 1 over here, and then you just keep it there and allow the helper functions to go and access it and modify it. Accessing it is okay, but modifying, that's where you will get into trouble, because say this data may be not available or to be modified by the original functions that's provided by the class. But when you're doing this, you have access to the self, and then you're able to make changes to it. That's where you will get into trouble. So be careful about that. And yeah, so that's it, and that will works fine. Is there anything else I would talk about? So yeah, I think I covered all the things that I want to cover. So so that's it. That's the topic about on this the main topic on about this video. So I'm going to start a video again right after this, so that I will actually start talking about the implementation of this card generator. So stay tuned for that. And with that, hope you enjoy this video, hope you learned something, and we'll see you next time. Bye bye.